Kavita ma'am, good morning ma'am.
Satish,
Good morning, sir.
Satish sir, start பண்ணலாமா?
Shall we start?
Satish sir,
Satish sir.
live போயிடுங்க, start பண்ணிடலாம். Vaishnavi, be ready ma. Vaishnavi, please.
Okay, ma'am. Can I start, ma'am?
Yes, ma'am.
Good morning to one and all present here. We, the School of Commerce, have immense pleasure in welcoming you all for the 5 days national level webinar series. Let us begin the prayer song by Sai Ganesh, Shift 2 of BCom Corporate Secretary.
देह शिवा भर मोहे है शुभ कर मन ते कभू न टरो देह शिवा भर मोहे है शुभ कर मन ते कभू न टरो न डरो अरे तो जब जाए न डरो अरे तो जब जाए लड़ो निश्चय कर अपनी जीत करो निश्चय कर अपनी जीत करो देह शिवा भर मोहे है शुभ कर मन ते कभू न टरो हर सिख हो अपनी ही मन को हर सिख हो अपनी ही मन को लालच हो गुण तो चुरो लालच हो गुण तो चुरो दह शिवा भर मोहे है शुभ कर मन ते कभू न टरो जब आपकी ओर निधान बने जब आपकी ओर निधान बने अत हीरन में तब जूझ मरो अत हीरन में तब जूझ मरो देह शिवा भर मोहे है शुभ कर मन ते कभू न टरो शुभ कर मन ते कभू न टरो शुभ कर मन ते कभू न टरो थैंक यू सो मच
Thank you, Sai Ganesh. Now I invite Dr. T.K. Avai Kodai, ma'am, Head PG and Research Department of Commerce, to welcome the gathering.
Very good morning to all of you. I deem it as my privilege to welcome our most revered General Secretary and Correspondent, Mr. Manjit Singh Nayyar. It is indeed my pleasure to welcome our most dedicated principal, Dr. M.G. Raghunathan, who has been a great pillar of support for all of us in all our endeavors. I extend a warm welcome to Vice Principal, Shift 2, Dr. N.C. Rajashri. I also welcome our Dean School of Commerce, Dr. Geeta, who has put in all her efforts in organizing this 5 days national webinar. I extend a hearty welcome to our beloved resource person, Dr. K. Uma Devi, Assistant Professor, PG and Research Department of Commerce, and I feel very proud to say that she belongs to our department. I extend a warm welcome to the deans and heads of various departments, coordinators, faculty members from the various departments of Guru Nanak College and other colleges. Finally, I welcome all my dear and loving students who are attending today's webinar on machine learning, a practical approach, and I am sure that today's webinar will be of great use to them. I once again welcome all of you to day one of the 5 days national level webinar organized by the School of Commerce. Welcome one and all. Thank you.
Thank you, ma'am, for the warm welcome. Now I call P.S. Sridharan, Associate Professor, Corporate Secretaryship, Shift 1, to introduce the resource person of the day.
Thank you, ma'am. Good morning to one and all. I take immense pleasure to introduce the resource person of the day, Dr. K. Uma Devi, Assistant Professor, PG and Research Department of Commerce, Guru Nanak College, Chennai. She has completed MCom, MPhil, MBA, PGDHC, PhD. She holds various positions in academic level. Name a few. Head, Department of Corporate Secretaryship, 1996 to 1998, Jaya College of Arts and Science, Chennai. Head, Department of DBA, 1998 to 2005, Jaya College of Arts and Science, Chennai. Senior Scale Lecturer, 2006 to 2007, Christ College, Bangalore. Head, Department of BBA, 2011 to 2013, Guru Nanak College, Chennai. She holds a vast teaching and research experience, undergraduate 27 years, postgraduate 12 years, and research 8 years. She has recipient of various awards, name a few. Organizing Women Educator and Scholar Award 2021 by National Foundation for Entrepreneurship Development, Coimbatore. Best Teacher Award 2020 from Besto Edurex International, India. Republic Day Achiever Award, Best Faculty, Commerce, HRM for the year 2017-18 by Integrated Intelligent Research, India. Best Faculty Award 2018 by Crafts Educational Charitable Trust, India. Best Paper Award in National Conference on Innovative Strategies for Corporate Management. Best Paper Award in National Conference on Financial Market Issues, Challenges and Way Forward. Best Paper Award in International Conference on Transformation in Industry in an Era of Digitalization, Challenges and Opportunities. She holds various positions in the field of research, life member, International Economic Development and Research Center, research supervisor and PhD guide for University of Madras, currently guiding 4 PhD research scholars. Peer reviewer in 5 international journals, Web of Science group journals, Asian Journal of Economics, Journal of Business and Accounting, Journal of Applied Science and Technology, Journal of Education, Society and Behavioral Science. She has guided many projects as a supervisor for MBA, University of Madras, Annamalai University and IGNOU. She has presented more than 25 research papers, national, international, recent conference and seminars, and participated more than 30 workshops. She published many research articles in various high-impact national and international journals. Invited speaker in 6 national webinars. She holds editorship of 3 national and international journals. Associate editor of International Journal of Research in HRM, editor Guru Nanak Journal of Multidisciplinary Research, editor for newsletter Banyan Enclave 2015 to till date. She has published 2 textbooks. Business Management by Dr. K. Uma Devi, Business Communication by Praveen Kumar and Dr. K. Uma Devi. She holds various positions in college and university level. Women Student Forum Coordinator 2021, Core Committee Member IQAC 2015 to till date, Board of Examiner for University of Madras and other universities, Chief Examiner for BBA and BCom Board, University of Madras, Member Board of Studies, Guru Nanak College, Autonomous, Add-on Course Coordinator 2015 till date, Placement Coordinator 2015 to 19, Vice President, Commerce Association 2014 to 2016, Fine Arts Secretary 2011 to 2013, Trainer of Soft Skill and Personality Development for UG and PG, Coordinator for Maharani Vidyavati Scholarship GNC. She organized 17 events for the past 5 years, name a few. Organizing Committee member of National Conference on Emerging Trends in the Functional Area of Business, conducted by PG and Research Department of Commerce 2016. Organizing Committee member of Strategies for Quality Enhancement in Higher Education, Conference IQAC 2016. Coordinator, Green Plantation. Coordinated Special Cultural Activity for Autonomous Committee Peer Team. Organizing Committee member of Workshop on Pedagogics for Excellence of Academia, conducted by IQAC on 2016. MC for National Science Congress Conference, conducted by Gill Research Institute 2016. Core Committee organizing member of Guru Shiksha 2019. Convener of Women Students Forum event, inauguration and orientation for freshers 2019. Organized this scale of women for 1,000 to start business in association with Women League Foundation 2020. Organized International Women Day Celebration 2020. With a few words, once again, I welcome our resource person. Thank you, ma'am.
Thank you, sir, for the sweet introduction. Over to the resource person. Ma'am, please.
A very, very warm welcome and good morning to one and all present here. Sir, Sridhar sir, thank you so much. Before I thank everyone else, thank you for the wonderful introduction. I myself is overwhelmed to listen to these things.
Great
Thank you
achievement,
so much.
ma'am.
Sir, thank you so much.
Yes, ma'am.
Warm welcome, and I thank my head of the department for having given a beautiful welcome address and welcoming me as a part of this webinar. Thank you so much, madam. I thank Dr. Geeta, the Dean Commerce, for having arranged this webinar, which is extensively going to be a real eye-opener in various fields. And all my dear friends, participants, welcome to this, and thanks for giving me this opportunity. Of course, I will definitely not leave away our principal, sir. I know today he is not available with us in absentia. I thank him for always encouraging and motivating us to be doing something new, or do something innovative. So out of my comfort zone, today I'm going to take up, or I have come out with this particular topic called as machine learning. Some of my friends immediately came out and asked me, Madam Commerce, machine learning, what is this? So I said, just watch out. I've tried certain things which will be really useful, and where we can put it out both for the commerce and the non-commerce staff and the students. So with these words, I thank everyone, and let's move on to this presentation. Thank you. Ma'am, I would like you to just let me know whether the presentation is visible.
Yes, ma'am, the presentation is visible.
Right. Okay. So, welcome all again. Good morning. Today, we will do a small learning on machine learning, a practical approach. The aim of this is to introduce and guide you to the non-code machine learning, and pick, or we call it as a kindle your interest, so that you can learn further and apply this ML in your fields successfully. Now, before we start into what are the topics which I'll be discussing with you and making you know about what machine learning is. So, we'll go with the definition, what machine learning is, why machine learning, what is the purpose of machine learning, and what a disadvantage are we going to get across this machine learning, what are the methods of machine learning, the available software for machine learning, and I'll be giving you some examples which we have worked out. So I'll work out with Microsoft lobe face mask deduction. Then we'll go on with what is Weka. With this Weka, I'll again come out with two experimental things which I have done. That will be your transformational leadership identification and MBA, we call it as market basket analysis. Right? So we'll go with the first one. What is machine learning definition? So anything to define with, we say what it is. I'm sorry. So machine learning, it is a branch of artificial intelligence, and now that machine learning has become very, very popular, and every one of us are into the usage of this. And here what does the machine learning does is, where the machine learns from the data and improve its accuracy over time without being programmed to do so. In machine learning, the algorithms are trained to find patterns and features which helps the ML to make decisions and predictions based on the new data. This is a simple definition to say what machine learning is. Going into why machine learning. Hope my slides are clear. So here we go into why, yes ma'am, why machines, why, thank you so much, sir. Now, there are few reasons I've given you. There are a huge amount of data which is generated, which we call it as big data. And how this is generated? Due to many sensors, like when we use mobile, smartwatches, connected household devices, IoT devices, etc. We generate huge data and computerized data in every field of business life, business and even in life. Now, for which a machine learning becomes important. Every field need a data analyst who is adapt to ML. So there is a plenty of job opportunities which is coming up. Another thing is, like if you look into globally, the machine learning jobs are projected to be worth almost 31 billion by 2024, and that's an annual growth rate of more than 40%, where the job opportunities are going to be wide open. This is not only for the people who should know the programmer, this is also for the non-programmers. There are no-code ML builders and GUI, which we call it as graphic user interface software too, so that everyone can use this ML in their field to enhance business decisions. Now, for example, to give you the entertainment programs, the entertainment which has been taken up, or the creative field, which is a non-programming one, and here also many of us, like, they can use this ML. And in a very simple way to tell you what this ML and how we are using it, every one of you do a Snapchat, TikTok, Instagram. Now all these are also involved into using of machine learning unknowingly by us, right? So this is the reason why we have machine learning. Now, these are few uses of machine learning. I've explained few of those. Number one is your digital assistants. The Apple Siri, Amazon Alexa, Google Assistant, and other digital assistants are powered by natural language processing, which we call it as NLP. Now, this NLP is like, it need not be with a particular word to be said, and only then they will specify and they'll use it. Simple words. Alexa, tell me, today will it rain? Can I carry an umbrella? Right? Any normal language, a natural language, will also make this machine learning be applied. So the powered, as I said, NLP, a mobile machine learning application which is enabling the computers to process the text and voice data and understand the human language in a way how we will do. Okay, a very, very normal natural language can be processed. This is also, we can call it as a voice driven application, like we use it in GPS or speech recognition softwares. Even there we have the machine learning being used. So it's for the first thing, which we call it as a digital assistance. The second thing, the second advantage or the use of machine learning is recommendations. Here I have given you a few examples there. We have deep learning model drives. Now, when we go for, when we browse, when we go for a purchase of certain things, or we are browsing out certain things. Now, what happens is this deep learning model comes out with some recommendations. It pops in, like if it's like if I'm in the Amazon, it immediately pops in and says, people also like this. just for you. It recommends, right? Having just, it is, you have not asked it to do, but then it learns. And when you use it, maybe in Amazon, Netflix, Spotify, and other retail, entertainment, or even travel services or job services, immediately it will show you that these are all the recommendations. You can also browse into these, right? So that is when we have the use of with digital assistance and recommendations. Some more uses: cyber security and medical image analysis. Now, cyber security, machine learning can extract intelligence from incident reports, alerts, blog posts, and more to identify is your potential threats. It can even advise the security analyst or accelerate response. A lot of things you can get as an input from the machine learning, right? That is how it helps the cyber security. The next one you have is your medical image analysis, where machine learning again it can be used there. See, there are different types, or a lot of types and volumes of digital medical imaging data, which have exploded. You will get plenty of informations. A lot of informations are available, and when we take up as a human, there is always an opportunity when we analyze or diagnose so many data. There is always error which can happen, human error, which we call it as. But then when we apply this machine learning, the error can be reduced or minimized to the maximum. Right? Now, for example, if you take up the cancer, this can be deducted by using cancer imaging analysis. I've given you a picture here where we have the eye fundus. The internal part of the eye can also be can be used or can be deducted. The disease or various diseases in that eye fundus can also be deducted through machine learning. Right. So these few purposes which I am giving you, or the usage where the machine learning can be done. The next one is again a self-driving car. Now in this, a car which requires a machine learning, like if you look into the image, they must continuously identify the objects in the environment around the car, right? They can predict how they will change, how they can move, what are the obstacles available, where is the lane of parking, right? What are the objects which is disturbing them? All these things will be identified by the machine learning. This is where you say the Tesla cars have come into the autopilot mode, and even Google self-driving cars are being available. Now this will identify each and every obstacles, and it will let you know how we have to proceed further. If you're going to park, it will tell you how comfortable it will be without, disturbing the other objects in and around you. So this is also where we use machine learning, self-driving cars. There are other uses where we say it can be used in remote sensing satellite image, agricultural crop disease identification, image classification of plants, animal species, and so on. Now, I'll give you one example. There is the, for deducting, as I said there, the agricultural crop disease. So the Plantix app is something which an farmer or an agriculturist can use it. This turns your Android phone into a mobile crop doctor, with which you can accurately deduct the pests and diseases on crops within seconds. Now, the Plantix app, it covers almost 30 major crops and deducts 400 plus plants which has been damaged. And just by taking a photo of the sick crop which is available, this can identify and tell you what disease is being affected to that particular crop. And this app has come out in around 18 languages and has been downloaded for more than 10 million times. Now, this makes the Plantix, the app, the #1 agricultural app for damage reductions. Not only for damage reductions, you can go for pest disease control, and definitely this will improve the yield for farmers worldwide, right? And this can also be used, this ML can also be used in entertainment and VR, which we call it as a virtual reality. And if you have come across playing chess, that's by using a deep learning technique. And we have Snapchats, Snap cameras. All these are areas where you can use machine learning. Okay. The other uses where we can come across are deep fake. Now, what is this deep fake? This is basically, it takes video and audio of a person and transfers it to another person's image. Maybe you can take it for the entertainment, recreation of classical actors, or even dead actors in films, and even sometimes for fun, when you use these. Now, if I have to put an example, a Trump talking like Obama is very famous nowadays, where it exactly drives the entire picture. It completely converts, and you feel that the other person is talking. So this is a deep fake which is being used by the ML, machine learning. The next one is contextual online advertising. Now, machine learning and deep learning models, they can be evaluated on the content of web page, right? Not only on the topic, but even the nuances of the author's opinion or the attitude. It will try to help out. Now, I'm going through my mail and I'm only reading out some of the text. The machine learning, finds or learns what the context is, or the opinion of the author, or the attitude of the author, and comes out with some advertising stating that these are all things which you can also browse, right? Depending on my just contextual online part. So that's another use. Next is the chatbots. Now here I'll tell you, most of us use Geo. Please go into this My Geo, and you will find that you will have the app there, the Geo complaint chatbot. Go there, you can find that it is in the WhatsApp. You will find that you can go, you have some complaint, you click, just type on that, what's the complaint, and you can see that you get the reply from them, what it is. So that is one part of your machine learning usage, right? So it can be used as the combination of pattern recognition, your NLP, or a deep neural network, right? You can even try this at the end of the session. You can try if you have a Geo app, right? Even in shopping center boards, we have technical support boards which is another use of ML. Then we have fraud detection. Now this one is, I've been traveling many places, and I find that my credit card has been lost. Now what happens is, and someone else is using it. Now how does this machine learning come into this? Now here we have the machine learning regression and classification models. Now what it tries to identify is, for example, the transaction. Now card is lost and someone is using it. It identifies the transaction which is happening in a new city, or the amount spent. Usually I take up only thousands or 10,000, not more than that. And now you find that the amount spent is more than lakhs. Or the time, the unusual time the card has been used. I usually go for my daytime usages, but then you find that it has been even in the night. Now, this will be indicated as, to the bank. Immediately there will be a message, or it will go on to say that there is some suspicious spending, right? This is an example. So similarly, you can have for various fields, the fraud detection can be used through machine learning. The next one we have is spam detection in email. Every one of us come across this. How does this go into the spam? No, I don't tell the machine to go into, I don't ask my computer to go and say that, put my things into the spam. These are all again being used or deducted by the machine learning. So they will look into that how, a consumer or the person who is using the email, the author, what are the ones which he actually reads, or the ones which he deletes, or one who he just ignores, doesn't want to read it. This is one way of the ML learning that these are all not important for the author and puts them into the spam. Sometimes you find that there are advertisements coming up like saying that the address, the words which they use, huge discount, click on this urgently, or pay now, or get 20% returns. Now all these words are being deducted by the ML, and that the ML feels that not important for the author and goes into the spam folder. So these are few ways or the advantages, or not advantages, yes, where we find that the machine learning can be used, right? So I'm just going to show you, as I said, these are all the uses. I'm just going to give you, look at this. Now, if you deeply watch into this, there are some green quotes given here, right? They are called as the label. So when we train the ML, now this is whale watching. Now look at this. When the ocean is plain, when you have only the water shown, it says it is being labeled as ocean. And when the whale comes in, automatically it says there is whale watching. Now this is a training. I'll tell you how this training is also being done. Now if you look into this baby, the baby monitor, it automatically, it's been labeled. It's sleeping. When you open up the eyes, when the baby opens up the eyes, it says it is awake. These are the unusual uses. The other unusual uses, like a beehive is watching, or the pollen is being taken up, or we say the equipment danger deductions, or look at that aerial image which is being said. Like if it is forestation tree, it is being shown as trees. If it is deforestation, when you don't have tree, it says deforestation. So all these are the other unusual uses which is being used by the machine language. Hope I'm making it clear, like what the machine learning is, and then how it is being used. That for, you have two things. When you have a visual machine learning, and for the data, non-visual machine learning. Now these are all the visual learnings which I've been putting across, right? Hope until here it's quite fine, and I've made it clear. We'll move on to the next one. Some of the disadvantage. Now when we say every time there is an advantage of a particular usage of a technique, definitely it will have a disadvantage. But in this case, even this disadvantage, it's like a trial and error basis. They try to find out the disadvantage, and it is being pointed out when they do the trial and error, and they use this for the betterment, to improve as to how it can be rectified. Now this is, again, I showed you there was a self-driving car. It's already programmed, right? Enough of inputs were being given. But what went wrong? It is the same car which I'm showing you. It's a self-driven car. Now here the disadvantage is, lack of sufficient data. This machine learning needs a lot of data. Now here you can see that the Tesla car couldn't differentiate. What is this image which I'm showing you is, it couldn't differentiate the white overturned truck and the white sky. During the incident, it was white. So these two were not being able to identify by its, I could not be identified. So when the car has been programmed, if it is white, it's the sky, and you can just go through. There is no obstacles. So that's the learning which is already being done. But now if you look into this incident, that there was a truck which it could not identify, and it crashed. So there are such lot of accidents which is involving into the driving cars. Now this should not be taken as a disadvantage. I think this should be taken as, like, the data can be improved. How? Now this was you found that there was an accident happened. Now how can you make this a proper one? How can you improvise in this? How more of algorithms can be used in this should be worked out, right? So this is one disadvantage. Following which we'll have some more disadvantage. Now, This is a soap dispenser at Facebook. They have come out with usage of machine learning, and what they have done is they have trained the machine. The ML is being given all kind of inputs with the color of the skin. Okay. Now this color of skin, which we use the scale which is being shown to you, it's called as the Fitzpatrick scale. It measures the skin tone. So they have been making it train only by showing white or maybe little more softer to that white color. So when a black is being introducing his hand into it, the skin is black, the soap doesn't dispense. There is no soap dispenser. It is not dispensing. So this is where the ML suffers such algorithm bias. So this can be again rectified. The researcher has to take this as a programmer to see to it that why it has happened, right? So you have been training them to deduct if it is white skin, it says the soap has been dispensed. And when a black skin is being kept, it doesn't go into it. So these are few learning or the algorithms which again can be rectified, or the programmer has to think of what is to be done. So this is another disadvantage where you don't give sufficient data to the machine learning. Sorry. Okay. Usually we have, when we use an internet. Right. So some more disadvantages, the deep fake videos, even this can lead to unpleasant videos of celebrities or wrong perception of politicians. It can even be used to incite the violence. So again, that could be looked into, and how advantages this machine learning can be made. There is loss of job in the traditional field, as ML has been replacing routine inspection, but for as it was deducted that global report says that 2024 you will have more number of opportunities. See, we are in the trend, and now that we have to go in for learning these kind of techniques. So when you start learning, as I said, it is not only for the programmers, even for the non-programmers. So when you start learning more on this, go into drive yourself into these related works, definitely the job opportunities will come much more. Right? As of now, we may feel that the traditional field, there is a loss of job. Another disadvantage, ML may not be able to factor in emotional component. See, when we say a doctor, a physical doctor who examines you physically, looks into you, has some kind of emotionals contained to him. Now, a person who is dying, or when the oxygen level goes down, as a doctor, he can predict, or he will look into, say that what other supporting things can be given to the person. But as far as the ML is concerned, once it says that in the operative care, your oxygen level is going very, very low, it cannot judge immediately. It cuts the supply of oxygen. So that's another danger which is available. Again, here we have to look into how it can be rectified. So these are few disadvantages which can be looked for. Okay. Now going into the next one, what is this machine learning methods? Don't look into the chart and say, oh, what is this? I'll just highlight the important things and why these are being used. This machine learning methods will concentrate mainly on 4 types. 1, supervised learning, unsupervised learning, semi-supervised, and reinforcement. Now, supervised learning, machine learning, trains itself on a labeled data set. I'll show you also example how we have done this labeled data set. Okay. Now, what happens here is, that is, the data is labeled with some informations, which will help the machine learning model to classify the data. right? The computer vision, for example, a computer vision model designed to identify ripe mangoes, right? So what we'll show is we'll show the mango and we will label it as ripe mangoes. We'll show the unripe mango, we'll show and we will label it as unripe mangoes. And when we train them and when you put it into use, the supervised machine learning will learn these and it will differentiate and tell you that these are ripe and these are unripe mangoes. Okay, so it can even differentiate those categories. So that is your supervised machine learning. It is actually it makes the training easier because the result of the model is already defined, so it becomes, the training becomes much more easier. Okay. The unsupervised machine learning, now here it says there is no such labeling. We don't label things. It extracts the algorithm to extract meaningful features needed to label, and it is done on its own. It learns on its own. Now it will not have, like as I said, the ripe mango or unripe mango, you won't have any such labeling done. This will try to do it on its own. See, the best example which I was initiating earlier was like emails. When it goes into the spam folder, you have not made it make any supervision because you get plenty of mails, the machine analyst, plenty of it, and the data scientist cannot keep labeling the entire thing. So it learns on some of the words, some of the moves done by the author, and on that basis it tries to segregate or separates which is important and which is not important. So this is something which we call it as the unsupervised machine learning. The semi-supervised learning will be a mixture of both supervised and unsupervised. Now what is that, man? What does this mean? We will label a smaller data set and using that as a guide, it will try to extract the other larger unlabeled data set, right? So this is what we call it as a semi-supervised learning. This can solve problems having not enough labeled data, right? So also you can train the supervised learning algorithms. So semi-supervised, you can use it with a larger data also, where we will label a small group of it, and with the help of that, it will try to use the remaining. Reinforcement machine learning is a behavioral machine learning model. Now, this is also similar to supervised learning, but in this, the algorithm, the data, isn't trained using sample data. Right? In supervised, we said they have been trained using sample data. Now here we are not going to use those. Now the model learns as it goes by using trial and error method. Now the best example we have is we have come across the chess. I don't know how many of you have really played the game with the mobile and so on. Now this is where the chess machine has taken up to play the game. It goes, you have the physical person and the machine which is going to play. At the early start, you found that the chess machine said we will give only the rules. What is being given to the in the reinforcement machine, only the rules are being set. The knight movement, or the pawn when it moves, or the rook how it has to move, or the king which has to move. Only the rules are being set. How to play? How will the other party move? All these are being only done by the machine itself. It's called as the deep blue. The lane following algorithm in car as you go in with, similarly with the chess, and the machine learns on its own. The chess, it plays, it makes a trial and error, and finds out, okay, if this move is done, then this is what is the result. And this is what you call it as the reinforcement machine learning. A sequence of successful outcomes will be reinforced to develop the best recommendation or policy for a given problem. This is where we call it as the reinforcement machine learning. These are the four, which we call it as the methods of machine learning. Now let me go into this deep learning. I'll just explain to you later. Now I would like to highlight on this. No code ML. This is what we are going to do. Nowadays, you don't need to learn coding to develop and use machine learning. Everyone can use the trained models using no code machine learning softwares. There are a lot of softwares which I have mentioned. We have Big ML, Microsoft Lobe AI, Create ML, Data Robot, Fritz AI, Google Cloud, Make All, Microsoft Azure Automated Machine Learning, Runway ML, Super NO. See, the, teachable machine. This is another interesting one. A lot of no code ML are available. So let me see all these. When you really browse in, if you go in detail with this, it will take another hours to explain. I'll be showing you how we'll go into detail. You can look into the websites, you can browse in, but we will check how few of those which I have taken for a model, how we have worked on it. I'll show you those. Now this is, if you really look into, there is one mango which I have shown. Before going into that. Now let's see how easily we can make this ML being done with no code. So I have taken up one program which is mask deduction ML using Microsoft Lobe. Now what is that you have to do? First thing, download the free Lobe app, L-O-B-E, Lobe app from the lobe.ai. Start by clicking on, I'll show you also, start clicking on the new project and you can see the menus which is being displayed. We will try to import the image through the camera. I'll show you how this is being worked out. Okay, so the best thing is you have to first download the Lobe app from lobe.ai. Okay. Now here we have, there's a new project. I'm getting into this new project. There is an import button. Click on that. There is camera. I've asked my daughter to please train this. So thanks to Neha. Now what we are going to do here is, look at that, I'm labeling it. No mask. So you can show your picture and look at this mark which you can see here. You start clicking on this, it will take a lot of shots of the face, right? So as many, see, remember I said lot of data or algorithm has to be given. So take as many pictures as possible. So once it is done, you can click on done. Then go for the next one. Again, we are going to train them with another mode. Go to camera. Now here what you're going to do is, you're going to label it as mask. We have typed it here, mask. Now wear it. Again, click on the button shown here. Take as many images as possible because that will be used for training the ML. So more than 35 images were being taken. So here we have 29 with no mask. And here you have with the mask. 24 shots are being taken. Now you can see here, there is a training. Now the data are being trained, both with the mask and without the mask. So it takes some time to train. So here the training is being done. Now you can use these. Okay, look at the use. Now when you show your face, it says there is no mask. And when you apply or when you use the mask, immediately it labels and says there is a mask. right? You can just, I'm showing it again. These are the way this has been done at home. How? By using, the ML, you can take up these many. I mean, you can use those pictures. See, these can be used locally. The ML can be incorporated. Now, whatever we have, I've shown you the shots. These can be incorporated in security camera to allow access to only people. If they wear mask, they can be allowed to go inside, right? The security check. As I was telling, the ripe mangoes, when we do, I've also tried with that. When you have a ripe mangoes, you can go for deduction models, can be used for cameras to say that when a juice factory comes and asks for mangoes from the farmer or the agricultures, you got huge mangoes available. Now, how is that they will try to, take out which is the ripe one or not the ripe one. So here again, the ML, if you have trained it, it will immediately sort out and give you the ripe ones. So you as a staff of the students can also go into and use this and try out how interesting it could be. Right? The next one we go into is Weka. Now all the software we saw earlier slide was about visual data. Now machine learning, we need even the the non-visual data. The best no-code machine learning tool for the text and non-visual data is Weka, right? ML I used for the all the visual ones. Now Weka can be for non-visual. Now Weka, you can just look how the bird which is being projected there. It is a flightless bird species in the rally family. It is endemic into New Zealand, and this is what is shown as Weka logo. Weka, the full form here is, the abbreviations we call it as Waikato Environment for Knowledge Analysis. This is also a data mining machine learning tool which is developed by the Computer Science Department, University of Waikato, New Zealand. Weka is a collection of machine learning algorithms for data mining tasks. And Weka is also an open source software which we can use. Right. The main feature of Weka, this includes 49 data processing tools, 76 classification regression algorithms, 8 clustering algorithms, 3 for finding the association rules. We have 10 for attribute and subset evaluators. There are a lot of plugin algorithms also, which is for extents and even platforms to build the Weka. I have also given you the websites wherein you can download. If you are with the system, you can go along with me and you can get into this downloading of Weka, which will be, you can also work out along with what I do. Right. So here we are going into how does this work. So before going into how it actually works, I'll give you the few terms which have been shown. This is how, when you download, it'll be shown. It looks at Weka GUI, which is graphical user interface. There is a lot of interface in the Weka, and let me give you a small input on those. The first one is the Explorer, which we are going to work on. An environment for exploring data with Weka. Experimenter is an environment for performing experiments and conducting statistical tests between learning schemes. Knowledge flow is, this environment supports essentially the same functions as the Explorer. Only thing, extra thing here you have is, it can drag and drop the interface. A workbench. Now, this is a collection of machine learning algorithms, and it is being used for data pre-processing tools, which includes virtually all the algorithms in Weka. Right? Now, how does this work? Now, here I have the next one for you. This is how it will look like. It will have the open file, the open URL, the file which you have, you can open or feed your file, that's yours. Open URL is available, open database, and you can also generate. You also have a filter where you can choose. I'll show you how it's been done. You have a data analysis, which is shown in three. The results will be put in three places, right? This is how it will be projected, and we'll see how it works. Okay. And this Weka contains filters for discretization, normalization, resampling, attribute selection, transforming and combining attributes. They also, the results, as I've shown you, they are being shown in three different windows. So I'm going to show you how we are going to work. Now, if you click on the Explorer, right, I showed you the first one when the Weka is shown. We are going to look into the Explorer. When you click into the Explorer, you will have this menu displayed: classify, cluster, associate, select attributes, and visualize. Now, we are going to classify, where we say that we are going to train and test the learning schemes. Cluster will be learn clusters for data. Then associate will be learn association rules for data. Select attributes will be for selecting most relevant attributes. And visualize will be an interface, that is a 2D, two-dimension plot of the data. Now we'll see how we use this classify, associate in today's analysis. Now, I have taken up two examples. So quickly we'll go to. One is transformational leadership identification, which I have done as a research, and there were a few outputs which I would like to share with you, and market basket analysis, which we call it as MBA. The transformational leadership identification for the research, anyone can thereby who's doing a research can also try to implement this machine learning using this Weka and do the classification, analysis. So classification and supervised. This is the second example to find the association and unsupervised. Right. So here, before we start the transformational leadership identification, now first thing is, what I have done is, I have identified the transformation leaders who can guide the company through difficult COVID pandemic time. So I have chosen 5 competencies been identified as after having given a lot of review of literature, the 5 competencies were being taken up. The 5 competencies for each senior manager was related. And these are the 5 competencies, and it was being with the 360 degree evaluation. The 5 competencies were conflict management, influencing others, interpersonal skill, team leadership, problem solving, and decision making. Right. So what I have done is, again here, the 360 degree rating by the senior manager himself. Who are the people who have done it? The person himself or herself, and by senior manager subordinate, that is the peer groups. Then we had the reportee with them, the cross-functional managers. Now all these were being given the questionnaires to be filled in. The rating was done on 5-point Likert scale, where we have from strongly agree to strongly disagree, and the points were given from 5 to 1. The competency analysis was carried out by computing mean rating cross-functional members, peer groups, reportee, and self-rating of employees. And what I've done is, the total mean rating was computed and used for clustering and categorizing transformational leadership level. Okay. Now, when you put this data, how the file structure will look like, right? So how does this, and this is going to be a supervised learning. I'm making it clear. This is a supervised learning. We have already labeled the respondents and we are going to do on it. So this is how my file structure will look like. So here, I've given all these 5 competencies, and this QCL is where we have given the competency, and this is, I have already labeled them: medium leadership, low leadership, high leadership, and it's with the mean rating, right? So when we apply this I'll show you how the results are being taken up. Now this will, it will predict, that is Weka will take this file. How does it operate? The Weka will take this file. It will divide the data into training and validation set. It will learn from the training set and create a classifier. It will then predict the leadership based on learning and apply to the untrained data. That's your validation set. Okay? And you can very well interpret and use this for automatic classification of new data. Okay, so we'll also have a creating of confusion matrix. I'll tell you how this is applied. So this is what we're going to look into for. This is how we'll work. See, click on the Explorer, the open file where I've already created it. I go into my file. This is my file. I'm taking out the document, opening up my document. So this is CSV data file. So here is mine, leadership cluster analysis, CSV. I'm opening that. So here we have the competencies, and which has already been rated. We have medium leadership, low leadership, high leadership. So we'll only do, I'm removing away this total leadership because only based on these competencies we are going to analyze. Right, so I want to classify, so I choose classify, then go into the rules, and I'm going to use this tree, which is J48. And with no moment when I say start, you have the results which is coming. It's very simple. Only thing, you have to have the data. Now look at this, how I'm going to show the chart for you. It is not visually seen here. So I have given you here, see, plugins. I've taken a screenshot. Here, this is what is shown down. Plugins, I want graphs. So I want to have my data to be shown in graphs. So this is how it will be shown. You will have the results. Now I'm going to find the association with this results which has come in with the 5 competencies. Okay, so just to show you again the Explorer, when we click on that, I'm going into my open file which is already created. So I'm just taking into my file, opening the file, which is the CSV data file. This is the data. I'm opening that. These are my attributes. I've already done a QCL. Here it has been identified. We have already labeled these. These are all supervised training. With the help of supervised training method, we are doing it. Right now, what is that I want? I want to classify. So I go into classify. I choose the rules, and the rules I want them in the tree format. So I go into J48, and I say start. And once I give the start, the results are being given. And here, the down we have the plugin, which I have taken as a screenshot for you and shown here. So here we have the plugin, visualize tree graphs. So then once you click on that, it goes into showing graph. And here we have the graph which is being projected. Okay, so this is where the results are, or this is how the results will look like. Okay, see, now I said there was a confusion matrix. I'm going to relate that here. See, our classifier has got an accuracy of around 81.11%, which is very good. The Weka prints the confusion matrix in this, and what does it does is, it shows the accuracy of classification of leadership. As I said, we have labeled it already, medium, low, high. Now look at the first one. The first thing, where you can see that 27 instances of medium leadership are correctly classified, which is true positive, whereas 3 instances are classified wrongly, though it is medium, but it is showing in the low leadership, and 7, though it's a medium leadership, it is highlighting in the high leadership. So this could be a minimal error which is happening. Similarly, if you go into the second thing where we have a low leadership, there again 28 instances are shown predicted rightly, true positive, and 3 instances are, though it is low, but it is highlighted in the medium leadership. Right? Similarly with the 18 high leadership. So this is what we call it as, I have classified, I've used this term and I have made a classification of high, medium and low leadership. So this can also be used in the researches which you are doing. So how does, I've also had one graph. So this graph, see, when I say teamwork, what I'm going to identify is, if my teamwork is more than 16.1, then I'll check the influencing of others, that other category. Then if that is more than 19, then I say that it is a high leadership. If the leadership is less than 16.1, then I identify to say that it is a medium leadership. And if it is less than 19.57, I say it is a medium leadership. If it is less than and greater than 19.57, then you can check another variable, that is communication. And if it is more than 19, then we say high leadership. And if it is less than 19, which is medium leadership. See, when you start working on this, this will help you to find the association, right? So classify and find the association or cluster it. So the output, the earlier one which I showed, can be, to identify whether we can interpret on these notes, that is the leaves which I've shown you, the decision tree can be taken up, and based on the decision tree, the transformation leader can be identified. And if you have more of data, the output can be turned into even an app or into a website or even as a gadget, and you can use to calculate the leadership. Right? I'll take another 5 minutes. Please don't be in a hurry, because it's 11:06. I can see the time. We have that last one is your market basket analysis. Now, this is another analysis which we call it as MBA, and it is a technique which identifies the strength of association between pairs of products when you purchase together and identify the partners of co-occurrence. Right? So here I'll show you another example how it works. Right. So let's take the case of bread. When a person goes for buying a bread, he may not buy anything else. He might buy only bread. So here in the trolley I find only my bread falling down. Sometimes it happens, so there is no association. But in some cases you find that when he buys bread, he also buys along with bread jam. Right? This is an association. Sometimes some of them buy with the bread, the jam and cheese. Now this analysis, the analysis of this pattern of which we call it as co-occurrence, is market basket analysis. Okay. Now what are these two? They're called as antecedent and consequent. Now antecedent, the item itself, which I said as bread, will be antecedent. So when you look into, I buy only bread, in simple words we call it as antecedent. But when I go with them along with something else, you join, with another one part, then I say another item, sub item, then we call it as consequent. Okay, that's what is being given, where I say bread is antecedent and consequent could be cheese and jam. Now what are this support? Now support is, again, as I said, bread when I buy. So it's nothing but it indicates a relative frequency. It just support indicates the relative frequency. If there are a transaction, suppose I say 8 transaction of bread, 8 people out of 10 are buying bread. So we say 8 by 10, 0.80. If there are 7 transactions happening, wherein we say that 7 transaction of bread and jam, then we say 7 people out of 10 buy both bread and jam. Am I clear? Support indicates relative frequencies. And if there are 8 transactions of bread of 10 total, then we say that it is 8 by 10. And if there is a transaction of bread and jam, and 7 people out of 10 are buying both bread and jam, it becomes 7 by 10, and you have, it's basically a probability, right? It's basically a probability. That next we have is the confidence, where we say that it means out of those who brought bread, how many bought jam also? That's confidence. Support is the individual part. Confidence is when you go along with another one. So for example, the slide shows that, look at this, out of 8 who bought bread, 7 bought jam. So the confidence becomes 7 by 10 into 7 by divided by 8 by 10. So my ratio comes into 0.88. This means that 88% of those who bought the bread also bought jam. Right? And in this, we range, the confidence value range is from 0 to 1. And you can measure even the reliability of the. Now, why lift? Now, this is a very powerful insight into MBA, market basket analysis. And this can help to determine how accurate your predictions are. So, this lift value indicates, if you look into this slide, it says support plus, that is the bread with jam, divided by individual bread and jam. So, where you have the results have been shown here for you, where we say that if the lift, the relative answers that you receive is more than 1, this can be useful for marketers. And the combination of the items should be exploited by marketers. Okay. So here the lift, where your accuracy, to say that whether we can use it or not, the correlation, that we say that it should be more than 1. Okay. Now what I have done is, I have used this methodology or this technique in a medical shop transaction. Now, this MBA was used by me in this, medical shop transaction, where I had 5 transactions, transaction 1, 2, 3, 4, and 5, and the supplementaries which I purchased, like a paracetamol, Z supplement, multivitamin, diarrhea, thermometer, and so on. So we have number of people who are coming into, and I've chosen 5 medical shops were selected for this simple random sampling. And this is how the structure file will look like when we upload the data. When I uploaded, this is how it was being displayed. So I'm just showing you the file structure, how it has been uploaded. Now just look into this. I've marked it as 1001. In transaction 1, a person who bought paracetamol, I've marked him 1. When he buys paracetamol, he is also buying sanitizer. He is also buying diarrhea tablet and the mask, right? So similarly, I've done for transaction 2, 3, 4, and 5, and it is being marked as 1 and 0. See, the first thing you have to remember in this is all these are numeric. ML will not understand, or the Weka will not understand the numerical point. So we have to convert that into nominal. Okay. So here I have done the experiment for you. So again, open file, arif data. So here CSV file, again I have my data which have been put into. I'm going into my data. Again, my data has been taken up. So here we have paracetamol. See, first thing I'm going to change the numeric to nominal, which is very essentially needed. These are all unsupervised. Earlier one I showed you was supervised, and now we are taking up unsupervised. I'm applying that. I'm going to find the association. We are going to change from confidence to lift. I said what that lift was, how we're going to use it. And here we are going to have the confidence level. We say that it is true, the facts which are going to give here. Treat 0 missing. So I put it as false. We start, and no time you have the results. I'm making it a little hurry up. Now we have changed the number rules to 37. See what we get is the answers. It will show you the normal output. Now, if you want to find out what was so surprising in my entire process, you also get some surprising elements. See, for example, when I go for buying in this particular thing, when I went for buying, when the data showed that there was a purchase, we could find that when a person purchased these paracetamol, Zincovet or multivitamin, you also found that people went for buying acupressure slippers. That was a surprising thing, surprising rule. So you can even find this surprising rule. There is a rule therein where you can apply and find out. So for which, what you have to do is just not with the only these transactions, you can increase the transactions. I have shown you with 5, which is a normal result. If at all I have to find out something very surprising therein, I can go for more number of transactions to be shown. So I increase the transactions and the output, and in my 18th transaction, I could find that the paracetamol, there was a purchase of it, and along with that, I could find they have purchased the acupressure slipper. Now, this is generally something very different, and this can be used in relation to promote your acupressure slippers. We generally have high margin to customer to buy the paracetamol. Now, I'll show you. This is what the output was. When a person purchased diarrhea, along with that we had the thermometer. Then along with these two, there was also mask which has been purchased. Now again here the lift is more than 1.15. So it's very good. The association is very good. Again a reverse one where we have mask, we have diarrhea and the thermometer which has been purchased. But look at this 18th transaction. This is where I experimented and found that when the person purchased paracetamol, you had this surprising rule came in where the acupressure slipper was also being purchased. So this can actually help you out in buying various other, or even into to do a margin of customer to encourage, advertise or promote among the customers when they're buying the paracetamol to also uplift these slippers. Right. So this is what I have made for you. Hope I have given you a lucid explanation on what the ML or the Weka is all about, and made it little interesting because because these are things where you actually have to have plenty of time to be taken to explain. So hope I have made an more to explain these. Thank you so much.
Thank you so much, ma'am.
I'll just stop.
Thank you, ma'am.
Thank you, sir. Thank you so much. I know I've exceeded 15 minutes. I'm very sorry for that.
Okay. No.
Thank you.
No
Thank you.
issues, ma'am. Thank you, ma'am.
Thank you, Uma. It was very interesting, something new.
Yes, ma'am. That's right. Thank you so much.
Ma'am, super, very interesting, ma'am. Very
thank
new
you,
things
ma'am.
we learned too. Super,
Thank you, ma'am. Thank you so much. Thank you.
Wonderful presentation, ma'am.
Thank you.
Really quite interesting.
Yeah, we can actually go for all these if you have still more data. Still, we have got a lot of such interesting things. Google Flex, we have a lot of things, but time constraint is another one. So maybe at any other point, we go for it.
Yeah,
Thank
we
you
will
so
have
much.
one more session during
Thank
the next round.
Thank you.
Yes.
Thank you all. Thank you all.
Nice. Vaishnavi, ma'am.
Participants, if you have any questions, please unmute yourself and clarify your doubts. YouTube viewers, you can post questions in the live chat box. We will read it for you and ma'am will clarify your doubts.
Vaidavali?
Sridhar, wait பண்ணுங்க Sridhar, please. Participants, if you have any queries, please. Participants, if you have any queries, you can unmute and you can clarify your doubts, or you can post the queries in the chat box, the comment section. You can even clarify your doubts.
Padmanabhan, the difference between ML and AI, ML is your machine learning technique. It's a part of artificial intelligence. AI is your artificial intelligence. It's a part of that. Okay? Padmanabhan, am I getting you? I think ML is a machine learning. It's a part of artificial intelligence.
Thank you so much, ma'am. Now let us call M. Vedavali, third year BCom CS Corporate Secretaryship, to propose vote of thanks.
Thank you, Vaishnavi. A warm and a graceful morning to one and all present here. If time is money, then today you have spent millions for us. On behalf of the School of Commerce of Guru Nanak College of Arts and Science, it gives me immense pleasure to deliver the vote of thanks to this gathering. Our special thanks to our General Secretary and correspondent, Mr. N. Manjit Singh Nair, sir, who is a great support in all our endeavors. I take immense pleasure in extending my sincere thanks to our principal, Dr. N.G. Raghunathan, sir, for his never-ending moral support and motivation. I am so glad in extending my sincere thanks to all the heads of the department and other faculty members for their esteemed presence. I feel privileged in extending my sincere thanks to our today's speaker, Dr. K. Umadevi ma'am, for this wonderful and eye-opening and a thought-provoking session. Thank you, ma'am. I express my sincere thanks to the School of Commerce of Guru Nanak College for arranging this wonderful national level webinar program. Nothing ever comes to one that is worth having except as a result of hard work. I express my sincere thanks to the organizers of this wonderful event. Finally, and more importantly, my deep felt thanks to each and every participant of this webinar session and their cooperation. I once again thank you all and extend my best wishes. Thank you so much.
Thank you, ma'am. AK ma'am, thank you for your warm welcome address. So that is the inspiration to us. Always you leave that.
Thank you so much.
The ma'am கூப்பிட்டதும் immediate வந்து அழகா எங்களுக்கு ஸ்டார்ட் கொடுத்தாங்க, லீட் கொடுத்தாங்க. Always she is a good supporter. Thank you, ma'am. Thank you for guidance and support.
Madam, thank you so much.
Thank you all participants. I thank everyone for having first, given me the opportunity to first present something which I felt I had to do. I thank Srinivasan sir for having been there and all the participants and the teachers who have taken up their time to come and, do a little learning along with me. Thank you so much.
Thank you, Uma. Wonderful presentation.
Geeta ma'am, group photo ma'am.
Group photo ka ma'am. AK ma'am, 2 minutes ma'am.
Yes, madam. Yes, madam.
Thank you, Uma. Really wonderful. So we learned a lot. Machine learning na enna.
YouTube streaming line can be stopped.
Revati ma'am. Geeta ma'am.
Unmute yourself, ma'am.
Sridhar, please ask all the spectators to join. You can stop recording.
Yes, ma'am.
Streamline could stop.
Recording stop. Keep it.
Gayatri, all the heads, please join. Coordinators and heads. Coordinators and heads. What happened, Sridhar? No coordinators is unmuting the video.
Great session, Mama.
Yes, yes, thank you.
Pushotwan sir.